Good morning. My name is Todd Bodislaw. I'm with ProPlanner. I serve on the development team and also project management aspects for integration of our 3D technologies. Okay. I'm in a unique experience. I was a customer of ProPlanners for about 8 years. And I have since been with ProPlanner a little over 3 years. As we mentioned, they're in another location, but I want you to know that I'm here to help field any immediate questions, okay, that we can answer quickly, or I'll document questions, that, we can cover at the end of the session or at another time when it may be more appropriate. Okay, so enough about me. Thank you. And Sanjay, I'll turn it over to you.
Okay, thanks, Todd. This is Robin. Wow, how about that Demco presentation? It's hard to follow that. And CNH and McNeilis, great presentations as well. So we'll try to keep up the high quality of presentations here. My name is Robin Owens. I'm a sales manager focused primarily on the automotive industry. And with me, obviously, is Sanjay, manufacturing engineer dedicated to Demco. And for the next 20 minutes, we're going to discuss the 3D assembly visualization technology inside of Assembly Planner for different areas. So the CAD library is where we upload the CAD files and store all the revisions. The component library is where we store the parts assemblies, and we can view the 3D CAD models for parts and assemblies in the component library. And in this 3D, you're going to see adds a whole new dimension to this manufacturing engineering work. And we'll show you that. So in the virtual build module, so those familiar with Assembly Planner know about the consumption workbench, okay, which is a process planning tool. It helps engineers map parts to be consumed by each process. And the end result, one of the end results, is to ensure that the full BOM, the full M-BOM is consumed by the process activity, that there's no remaining parts after you finish your consumption, which is a common problem. So it's a very useful tool, but now we've taken it a step further and we've integrated the 3D product CAD. So you got this trilogy of manufacturing engineering data. Okay, so we got the bill of materials integrated with the bill of process, integrated with the 3D product CAD. Okay, so that enables us to perform this consumption mapping visually, leading to faster and more accurate consumption mapping. Virtual build module, we also integrate the 3D CAD module, with 3D views. We make 3D views because the engineers, creating the work instructions, defining the process, need to zoom into this particular part being consumed, right, and hide this and explode these and make that view that you're going to need in the future to work. You don't want to recreate these views. So that's what a 3D view is. And we have a secondary use of the 3D views where we publish the 3D views to the shop floor work instructions to show the operators the status of the CAD, the 3D CAD of the product at each process step. Okay, and lastly, in a virtual build module, we capture and edit images for the work instructions. They're stored in there, quickly changed using the embedded image editor inside the virtual build module. Line balancing, we use the 3D visualization technology also there, and we use it in the precedence when we define our precedence, right? Pre-line balance and post-line balance when we create our Yamazumi or stack-up chart where we make adjustments, get team buy-in. And so the 3D virtual build data helps us to better assign processes to stations and, again, validate the planned build sequence and find problems before the products hit the assembly line. Okay. Now, the example we're going to use today utilizes the final assembly of a header trailer, a Demco header trailer. So they were very nice to share this data with us and allow us to share this data with you. So I'm just going to quickly explain the header trailer here. So on the left in yellow, look at the yellow equipment, agriculture equipment. On the left, you have a combine, and the header is actually connected to the combine, and it's interacting with the plants, pulling into vegetables, processing them. Now, this header has been detached and put on a header trailer, and it's being towed by a tractor there. So trying to get this header to the field, right? It'll take up, if you don't detach it and put it on a trailer, it's going to take up multiple lanes of traffic. So you put it on a trailer and it'll just take up one lane of traffic. So that's what a header trailer is. And that's the example that we're going to show you here today. Okay, good. We got to share assembly planner here real quick. Okay. All right. So you can see here, let's see here. I'm in the CAD library, right? And the CAD library is where we upload our CAD files. So here we've uploaded, there's a header trailer. Here's a different header trailer, even, parts like a cotter pin or whatever. So this is where we upload now, and we keep each revision of the CAD files, right? As engineering changes come in. Now, one thing I want to say is, in the 2 years that Todd's been working with this, Todd and his peers, the people that have created this technology, they have yet to encounter a customer situation where they couldn't handle, the CAD file. There's a way. If we can, use the native CAD file, we use a universal file type like a JT or step file. So we're very confident that we can handle your CAD files. Now, I'm going to go over to component library. And again, a component library is where we store our parts and assemblies. Now, I want to just point out something here. So here's 5H00041, right? So that's part number, and then here's a description, right? Now, on top of that, on the left, we have our EBOM, and on the right, we have our MBOM. And so I want to ask you a question, a rhetorical question. How much, just think for a second, how much do you understand this assembly? How much do you understand this assembly? Now, if I add the 3D CAD here, now you can really see that this is a tongue, and it's got its ball hitch there and so forth like that. So when we're talking about adding a whole new dimension of understanding and capability, this is an example of what we're talking about. Okay. All right. I'm going to hand it off to Sanjay, talk about VirtualBuild.
Thank you so much, Robin, and good morning, everyone. I'm Sanjay Tangwale. I primarily work on site with our client Demco. Today, I'm going to walk you through our assembly planner's VirtualBuild module, focused primarily on addressing 3 major industrial problems currently faced by MEs, mainly how to validate that there is no part leftovers in our defined consumption of a unit. What does the product look like at different stages of production when the unit gets built? And we deal with a whole lot of engineering changes, right? That takes place in our day-to-day production environment, and how quickly one can update and manage the process work instructions each time when there is a change. Yeah. And how do industries currently handle this process? Well, it's a nightmare for most of us, right? First of all, the user needs to get into multiple software to capture all these changes, where the data won't be readily available. And moreover, it consumes a significant amount of time to gather all these data into a nutshell. And things can get even more complicated if you have frequent changes. Well, to address this, our experts came up with a powerful agile technology called the VirtualBuild module, which is a one-stop place that solves all the previously stated issues seamlessly and more efficiently. Before getting into the specifics, I will give you a quick overview on how to navigate the VirtualBuild module. Right. I'm in the assembly planner now, under the VirtualBuild. Right. The whole concept of VirtualBuild works on premise of workspaces, which includes assigning a routing or multiple routings, a CAD file or multiple CAD files. To start with, the user needs to upload at least one routing and one CAD file. The workspace basically combines the CAD file, consumption data, and all other process aspects together in one place. The VirtualBuild also offers an excellent user interface. Here's the process tree on your left, which includes your routing, the workstations on that line, and like the activities of each stations, and detailed work steps of each activities. And also we show the consumption records for the selected activity on top of the CAD viewer. We also have the CAD model tree and the 3D CAD viewer. And all these panels can be turned on and turned off in the panel visibilities, and also the users can drag and dock the panels wherever they want according to their user comfort. As Robin mentioned earlier, we use real-time sandbox data from Demco's head trailer product line. Demco have like 30 plus head trailer options with 300 different options in it. Now let's get into the specifics of our first problem. Here is a typical scenario. A new trailer unit is gonna like with specified model option combination is scheduled for build next month. As an ME, I need to validate that all the parts are being consumed in that unit. And I also need to make sure I update the process consumption if there is any leftover of the parts. We know we can do this, but how efficiently? How does our VirtualBuild tool fit in here? Well, if you look closely at the particular head trailer, this particular head trailer model, you can see this model has got multiple rear axles, couple of front axles, and plenty of tongue assemblies and whatnot. Yeah. Ideally, I want to see a workbench with a specific unit with configured model option combination. With our filtering technique, the user can filter entire workspace by a specific unit serial number or a model option combination. Yeah, here we go. And also we can filter by workstations. Let's filter a particular unit and see what actually happens. I'm going to select a model HT69 and a bunch of options which go into the product. And I'm going to search it. Right. Let me refresh the process data. Now, not only we show the CAD model is getting filtered here, but the entire process routing record is filtered within the workspace for the selected unit. Look at this. Second, yep. Let's get into the virtual build mode and let's go to the last activity. Right. Look at this. Like look at the CAD model now. Like now I've filtered a specific model option combination, which one with one rear axle option, with one front axle option, and just one tongue assembly, and so forth. Yep. Okay, I strongly doubt if there is any other software which can filter out a process and a consumption record and also CAD data of a unit with specific model option combination. Isn't it an amazing feature to have? Right, having filtered these units now, I'm gonna validate if all the parts are being consumed, right? We offer two different consumption validation techniques. As I navigate to the consumption editing mode, you can see our software is smart enough to highlight what parts are already being consumed. The consumed parts are highlighted in dark gray. You can see the parts which are unhighlighted or not yet consumed to this assembly. This visual effect alerts the users whether the consumption is fully mapped or not, or if there are any leftover parts. On the flip side of things, for the larger assemblies, it's really hard to visually validate the part consumption. In this case, we have something called BOM Compare. This tool validates the consumption more accurately, right? This is basically similar to our traditional consumption workbench functionality, but it's shown a little different in a much user-friendly way. The BOM Compare basically compares the consumption records with the bill of material and the bill of process by highlighting the changes and else identify the consumption gap in the unit. Okay, I have selected the options what we basically filtered, and let's see what happens now. Okay. Still loading. Right. What we got? Okay. We have 52 changes. Like we need to add. Now is like we need to add multiple parts, and like here seems I have seems my internet connection is unstable. Yep. Okay. I have multiple parts, and somehow I missed to consume these parts, and like these are showing in add. In addition to the addition, we have a lot of changes, which basically means I have added these parts correctly, but somehow I have a wrong quantity in there, or we have like different effective from dates, and we need to change those things. Last, and we also have a delete option, which shows these items are not part of the CAD model or bill of material, but it's consumed somewhere in the bill of process, and we need to delete these things out of the consumption, right? If the user is knowledgeable enough on knowing which parts are consumed on for which activity, they can just go to the specific activity and drag the part from the consumption workbench and drop it on an activity. Okay, it's a very useful tool, but like with the tribal knowledge, like this can be used more efficiently. In addition to this, we also map the consumption to an activity directly from the consumption editing module, where the user can consume the parts by a traditional method of adding the consumption through bill of material and also from our consumption library. We also offer consumption mapping by selecting a particular CAD node or selecting a particular CAD node on the CAD model tree and directly assigning to the activity work steps. Now I'm going to walk you through an example of how to map consumption for the rear tail lights that are not yet consumed. Let me navigate to the activity first. Yep, in the bolt-on assembly, and you can see these two activities are highlighted in light gray because this basically tells this activity does not have any consumption assigned to it. It's in the wrong mode. Yep. Let's go into the consumption editing and see how we can add the consumption through the CAD viewer. Okay, all right. I'm going to select the rear light activity, and I'm going to zoom into the part and select the part, and basically going to add it to the consumption, right? Also, I can add this parts from the CAD model tree also to on a specific work step level too. Okay, I'm going to install the grommet. So I'm going to go to the passenger side, highlight the grommet, and from the CAD model tree, you can see the selected part is highlighted here, and you can select to the consumption. Okay, let's go to the process again. I need to install the red light. So I'm going to select the light, and I'm going to consume it. Right. So this way you can add the parts directly from the consumption editing mode, and this is it. Like this is all what we can do from the consumption editing basically. And now let's go to our second problem. Okay, having already validated and defined the parts that are consumed on each activity level, our application is smart enough to link the part consumption records to a CAD model, which basically mean in the virtual build mode, the user can visually see how the unit is getting assembled. You can see as I navigate through the activities, you can see the trailer will get assembled. So I'm in the install rear end caps. The rear end caps got assembled. Install slow moving vehicle sign. Install rear light, driver side, rear light, passenger side. Install the slider base. So here, and so on, right? And you can see like how the product comes out of the second station, third station, and so forth, right? I'm not sure how many of you guys noticed when we are on the install the rear driver light, it was consuming both the tail lights instead of one. Okay. So this is because I just picked a part ID which is being used on two different instances in the CAD file, which is on the left side and also on the right side. The software doesn't know exactly which instance to show. So basically it shows both the lights when I go to the first activity. Okay. In order to address this issue, our experts came up with the unique instance mapping model, which can tie the specific instance to an activity. Currently, no other software, I don't believe like no other software is smart enough to filter the instances out cleanly without having any floating parts. I'll show you an instance mapping, what instance mapping will do it like to our tail lights. Okay, I'm on the activity and I'm going to select a midship grommet. It basically highlights where that instance is used, so we can see both the instance. I'm going to click the instance what I need and going to map it to the particular activity. So this way, like by instance mapping with the instance mapping, the tail lights will get assembled at the specific exact activity level. We also have a highlight mode. It's just an extension of VirtualBuild mode where the exact assembly gets highlighted when you step through the activities. Right. Here's an example of few. Right. Right. Let's root down to a final problem statement. How to update the document, update and document the process work instruction for the changed process efficiently, and how to tie back those work instruction to a shop floor viewer. Traditionally, how we used to do this earlier. Generally, we will be multitasking with 4 or 5 different softwares, one for viewing the CAD design, one slimping tool, doing annotations in the image editor, and most importantly, managing those stuffs and upload it back to the assembly planner and tie those things to the work instruction. And with the tons of engineering changes that comes through, we need to go through this painful process again and again and again. So like how can the VirtualBuild mode assist this functionality, right? Right. The VirtualBuild mode allows a user to create an SOP image for an activity or a work step level rapidly by just capturing the image directly from the CAD model. You can also take, let me show you an example. I'm gonna capture some SOP images for installing the slow moving vehicle light. I'm going to turn on the SOP images panel. Okay. I'm going to zoom into the activity and I'm going to select a particular work step. Okay. And I'm going to, oops, I'm in highlight mode. Okay. Okay. I'm going to select an activity and I'm going to capture an SOP image. Okay. Now what this does is it will assign the SOP image automatically on the selected work step level. Okay. In addition to that, we can take multiple snapshots of an same image, and we can tie it to the image editor, where you can later on you can go into the image. One of the use case of having the 3D views is that no one wants to show an entire trailer to the operator on the floor. By having the 3D views, we can capture exactly what the operator wants to see, and we can export it back to our shop floor viewer work instruction, and which will be the operator's default view when they go to the CAD view on the shop floor. In addition to this, 3D view can also be used for internal references while creating SOP images and so on. Right. And to sum up, the VirtualBuild is a very powerful technology where the consumption records can be validated and controlled in more accurate and efficient manner, even before the unit which gets to the production floor, right? And we can also visually see how the products get built on each stage of production. And the most fascinating part about having the VirtualBuild feature is that it brings together all the process, design, and consumption aspects together under one umbrella, which makes the change management workflow seamless. Right. That's it from my side. I'm going to hand over to Robin. He's going to explain the other extension of VirtualBuild module. Thanks.